Hello, Mindsetters, and welcome to it. This is Learn Extra Live's very first broadcast after the holidays. I hope you are learning a lot. My name is Abram, and I'm not alone. I'm having dinner. How are you, Dina?
I'm very well, thank you. It's time to get to term 2.
There's no more time to play. I hope the Mindsetters were enjoying our Easter school revision and learning a lot from them. But today, we're getting a lot into business as we say, welcome back, guys. It's time to work now. What's on the menu today, Dina?
Well, it's grade 10 to start up the show tonight, and we are going to be looking at trigonometry, that very new topic for grade 10s. So we'll be looking at some expressions, some triangle work, and join us just now.
Join us just now as Dina Go takes her place. Now, Mindsetters, let me tell you how you can join us and learn with us. Firstly, you can join me on Facebook. We are on facebook.com/LearnExtra, or on Twitter. Chat with me on Twitter. Let's treat one another at LearnExtra. And lastly, we have notes that we'd like you to download for free just to learn with us and be part of our show on our website, which are on learnextra.co.za/live. And now it's time for learning. Dina, take it away.
Well, everybody, as I said earlier, we were looking at grade 10 trigonometry. Now, that is a topic that is brand new at grade 10 level. In grade 9, you've never seen it before. So some of you may have already tackled that at school. Some of you, it's a brand new topic. And as the word says, trigonometry, tri, got to do with something with threes, and metry, the measurement of those threes, and what are those threes, and really, it's all about triangles. So that's what trigonometry is. It's the relationship that exists between angles and the lengths of the sides of a triangle. And we are going to measure sides of a triangle. We're going to measure the angles of the triangle. So everything that we're going to work with in trigonometry stems from the understanding of how these relationships exist and how we call these relationships. So trigonometry, all about the study of triangles. Now let's have a look at what we're going to try and accomplish in the next hour together. Firstly, we're going to define what the three main trigonometric ratios are. In other words, what do these terms look like? What do they do? How do they function? How do they operate? Then we're also going to look at the trig ratios in order to be able to find, there will be some unknown angles in the triangle, there will be some unknown lengths in a triangle, and we're going to be able to use trigonometry to solve those angles and lengths. Then something very interesting, we're going to look at the reciprocal ratios. What are they? What do we call them? How do they function? And finally, we're going to identify and use what do we refer to as special angles to perform calculations without a calculator. So let's get right to it, and let's go through the definition of the trig ratios. Now, the trig ratios are really defined by using a right angle triangle. So without having established a right angle triangle in any of the figures, these trig ratios would actually not exist. So it's very important that when we look at our diagram, we're working with a right angle triangle. And the position of the angle will enable us to be able to work with two special sides. The two sides that we refer to are labeled as either an opposite side or an adjacent side to the angle. Now, the side that is opposite the right angle triangle, or the right angle, the side here, because it's opposite the right angle, it already has a special name. It's already called the hypotenuse. So the side that's opposite the right angle is the hypotenuse. But now, if I have angle theta at C, or at vertex C, then this length that is creating this ray of theta is going to be called the adjacent. Adjacent simply means next to, so it's the side next to theta. However, the side that is directly opposite the angle theta that I'm mentioning, that side will be referred to as the opposite. If I change positions and I was now working from position A, can you see that this green side would no longer be called opposite because it's now the side that is next to the angle. So if this was angle beta, for example, this side would now become the adjacent, and this side would now become the opposite. Remembering that the hypotenuse is fixed. The hypotenuse can't change when you are changing positions in that triangle. So a triangle has got 3 angles. A triangle has got 3 sides. And the relationship between those 3 sides and 3 angles is what we will call the trigonometric ratios. Now, the hypotenuse is fixed, so it cannot change, but the position of these 2 vertices can change. And so we are going to define the ratios in terms of either angle theta or angle beta. Now, to make this much easier, I'm going to stick with beta. And when we define the ratio of the side that's opposite it to the side that's adjacent to the angle, when we're defining that relationship, it's going to have a name. When we define the relationship of the side opposite the angle divided by the hypotenuse, it will too will have a name. And when we're defining the relationship between the side adjacent to the side to the hypotenuse, it will also have a name. So those 3 ratios are our foundational ratios, are our fundamental ratios. And we will then work on the reciprocals to get our other 3. So ultimately, there will only be 6 ratios. Again, to repeat, the adjacent side is sitting next to the angle that you're referring to. So the first position to look for, the first focal point, will always be the angle that you are denoting, or the position that you're denoting. So let us go into what we call these ratios. The first one would be, if I take the side that's opposite the angle and I divide it by the hypotenuse, I'm going to get what I call, for those that are unfamiliar with it, it is called the sine of theta. So that ratio will always be reserved for the fraction that you create when you take the side opposite theta and you divide it by the hypotenuse. So there's a relationship between the angle. It is the side opposite the angle. So the angle will always work together with the side that you've chosen. They work in tandem. You can't work with the angle by itself. You need to work with the angle and the side opposite it. Then when we talk about the side adjacent to the angle, we will talk about the cosine of theta. Again, it's the side that's adjacent to this theta, this angle which we have chosen. Remember, the hypotenuse is fixed. The adjacent is the side that's next to it. So the fraction that we create by dividing the adjacent side over the hypotenuse side, when we are working with angle theta, it will be called the cosine. Now, the way that you write it, you'll see it on your calculators. It's been abbreviated to 3 letters. So it's now called SIN, but we read it as sine, and it's abbreviated to COS, but we know that it means cosine of theta. And then finally, if we take the opposite over the adjacent, then that will be called the tangent of angle theta. And for those that are getting to grips with the language, we talk about the tangent of theta, but we abbreviate it to TAN theta. So there doesn't appear that little word of, and the big word tangent falls away. Now, this is not to be confused with a tangent that exists in geometry, that is a line that is touching a curved surface. So these are 2 different meanings of the word tangent, but in this trigonometric sense, the tangent refers to a fraction that is made when you divide the opposite by the adjacent side. Right, so just to repeat, that would be called the sine, that would be called the cos, that would be called the tan of those angles, and they are formed by us having firstly chosen the angle, and the angle's position to the sides of the triangle will give us what these relationships are. So if we had to write this as opposite over adjacent, opposite of hypotenuse, this one as adjacent over hypotenuse, and this one as opposite over adjacent, and just taking the fractions made up of just the first letters of the ratios. So I've just chosen the opposite over hypotenuse, the adjacent over hypotenuse, the opposite over adjacent. So I've chosen just the fraction letters. We can actually see that there's actually a pattern, so that you need to remember what these are. And so we would take that sine will go with opposite over hypotenuse, cos will go with adjacent over hypotenuse, numerator denominator, and tangent will go opposite over adjacent. And if we put all those three together, we get a nice acronym that we can remember. And there's our acronym, SOHCAHTOA. So we were reminded of which side goes with which, because remember, there are three sides and there's three ratios, and we need to get them in the right order, otherwise the fractions won't mean the same thing. Right, so let's see. What about reciprocal? What do we mean in mathematics if we talk about the reciprocal? The reciprocal is a value that when you multiply it by a given number, your product is 1. So if we have 2, for example, and we want to multiply it by something to give us 1, what is the something? And the something is what we call the reciprocal. The reciprocal is the value that when you multiply it by a given number, you're going to get 1. And that will happen when you take the number and you make it into the denominator. So 2 times a half will give you 1. So we basically say that when you reverse the position of that given number, so if it was in the numerator and it becomes in the denominator, or vice versa, then, for example, if you said a half times what gives you 1, then 2 is now in the denominator. I've got to make it into the numerator, so it would be times 2 over 1. So when that given number changes position in the fraction, it then becomes the reciprocal. So the reciprocal of sine theta would be 1 over sine theta. And that's when we change positions, numerator, denominator. So you now have hypotenuse over opposite. And that 1 over sine is actually given a new name. It's not on your calculator. Completely new name, cosecant of theta. Okay. Cos, this is reciprocal. Also a new name, it's called the secant of theta. And these you have to memorize because they are definitions, they are standard definitions. And the reciprocal of tan would be the cotangent of theta. Okay. Right, so let's see how these would work. Use a calculator to find the trig ratios rounded off to 2 decimal places. What is the cos of 12 degrees? Now, the instruction says use a calculator to find the trig ratios. What a calculator is not going to give you, it's not going to give you what the adjacent over the hypotenuse is. It's not going to give it to you in that raw fraction form. It's going to give it to you as a decimal. But what picture you should be getting is that there's an angle of 12 degrees, and when I take its cos, and I think that's just too crazy to make that 12 degrees. Let's just make this a little bit more reasonable, a little bit more real. 12 degrees would be about there, okay? That's about 12 degrees. 12 degrees would give me that as my opposite. That's my adjacent, and that's my hypotenuse. So if I took that A divided by that H, I would get cos of 12. And we want to know, what does that fraction come to? Now your calculator is able to do that for you. You press cos, you press 12, and the calculator has been programmed to know that that 12 is degrees that you're talking to. You must also make sure that on your calculator you've got a little d that shows that you're working in degrees. Because some of you haven't worked with radians or gradians yet, and that's a different measurement of, or a different angular measurement. So if you don't have degrees, you're going to get a very different answer. So 12 degrees is what? 0,978. Remember I said to you, it's not giving it to you as a fraction, it's giving it to you as a decimal. 0,978. Right. Round it off, and then it's specifically saying, let's round it off to 2 decimal places. Let's just get back there. To 2 decimal places, can you see? It would be 0,98. So that would give us 0,98. So I'm using my calculator as opposed to my triangle, but I'm giving you an understanding of what this cos 12 degrees would actually mean with a picture. What would tan of twice 20 degrees be? Well, that's the same as tan, and I need one angle. So tan of what? 2 times 20 would be 40 degrees. So I'm actually working with 40 degrees. So if you think about your triangle, you'd have a 40-degree angle, and you want to know what is your opposite divided by your adjacent. Okay? But your calculator gives that to you. And we press tan of 40 degrees, and we get 0,84. 0,84. Now that's interesting. Here we had twice of 20 degrees as part of the angle. Here we have twice the tan of 20 degrees. What does that mean? This simply means that this 2 is being multiplied by whatever your ratio of tan 20 degrees is. So that would be 2 times what my tan 20 degrees is. And if we go into our calculator, we have 2 times, and we put it into the calculator as we see it, tan of 20 degrees equals, and we get 0,73. So we get a value of 0,73. So here we are doubling the ratio, we are doubling the fraction. So this would be the same thing as the twice of your opposite over your adjacent, with an angle that you're referring to as being 20 degrees. Whereas here we want to double the angle first, get a new angle, and then we are taking a ratio of opposite over adjacent where the angle is actually 40 degrees. So I hope you can see that doubling the angle here, here I'm not doubling the angle, I'm doubling the ratio. Very important difference. Okay, and then finally, no, we've got 2 more. Sec 60 degrees, what would that be? Well, let's firstly define sec 60 degrees. We've looked at previously, in the previous slide, that the reciprocal for cos is sec. What I didn't give you is I didn't give you the short name. This would be sec theta, so we just take the first 3 letters. This would be cosec theta. We wouldn't be able to take the first 3 letters here, otherwise we'd have a cos that's being ambiguous. So we have to take cosec of theta here, and in here we've got to get to the cot of theta. Okay, so sec is really the reciprocal of cos, and if we now go to this sec 60 that we were busy with, okay, what does sec 60 mean? It's the reciprocal of cos, so it is the same as 1 over cos of 60 degrees. Okay. Now, your calculator does not have the reciprocals on it. You've actually got to place those into the calculator so you get the reciprocals out. So you need to know which ratio goes with which reciprocal. So what the calculator does have is the cos 60. So we would go cos of 60 degrees, but we're not looking for the cos of 60 degrees. We're looking for 1 over cos 60 degrees because we'd like the sec of 60. So we would take that value, and then we would take the reciprocal. And now you'd look for your reciprocal function, which is the 1 over x button, which is over there. So you would take the reciprocal, which is to the minus 1, and you'd get 2. So cos of 60 is, you actually do it as a 1 step on the calculator. Okay, so cos of 60 is actually equal to 2. Okay, so your keying sequence would be cos of 60 degrees to the minus 1, because a negative exponent means you are taking the reciprocal of the given base. And then the cot of 45, and we'll do that in there, the cot of 45 is 1 over tan 45 degrees, and that's on your calculator going to give us tan of 45 degrees, which we get as 1, and then we need to take the reciprocal of that, which is also 1. So that would be tan 45, reciprocal is 1, so that is 1 as well. Okay.
Well, Dina, on that note, I think we should take a net break. Mindsetters, I hope you're still learning a lot and are interactive with me over Facebook. Well, having said that, Dina has worked so much, I have a quote that I want to leave you with just before the break. It says, one important lesson in math that everybody should live according to and apply in their lives is that always be careful of the signs. See you after the break. Welcome back, Mindsetters. I hope that you're still learning a lot. Great hands, we're still doing your trigonometry, and I'm on the page chatting with you. Our Facebook page is simple, facebook.com/learnextra. And you can also tweet me on Twitter. I am on @learnextra. Also catch our words. Oh.
Happy birthday to you.
Oh my goodness.
Happy birthday, dear Abraham.
Oh, thank you.
Happy birthday to you.
Well.
It's the first time I've ever sung happy birthday on live TV before.
Oh.
So you better feel very special.
I am honored, actually. Guys, this only comes once. Thank you very much.
Hey, Dina, can you believe it's his birthday?
Oh no,
Awesome.
I still feel young, but I'm really grateful. Thank you very much, guys.
Okay, so guys, this is from all of us at Mindsetters, one of all of you Mindsetters out there. This is to you. So now, Abram.
Thank you,
I see you've
Dina.
got that plate there. What I'm gonna
Yes.
do, I'm going to take your plate back, but you can cut it. You know when you get to the bottom, you've got to scream. That's apparently what you do, right?
Okay,
Hey.
maybe you should come close to me.
Okay. Is the cameraman following us?
I hope so.
Yeah,
Should
he
we
is.
stand in front over there? In front of your
Maybe.
Hey, what does the director say to you? Okay, all I need you to do is cut and scream.
And scream.
No, when you get to the bottom, right, Mindsetters?
Okay, let me.
1, 2, 3.
It's full of chocolate. Very yummy. And
Scream when you get to the bottom. Scream.
yippee! Oh, thank you very much.
Oh,
I'll have the rest.
You know what you'll do?
Yes.
Okay, Mindsetters. Okay, I can't hand it through the TV. So, Abram, in the break, you and Dina can get some of your chocolate cake, as well as the director there. In the
Sorry
back
for the
there.
guys at home.
Sorry, guys. Wish Abram happy birthday on our Facebook page. It's facebook.com/learnextra. You can also tweet him @learnextra. It is his birthday, guys, so you all better be tuning in. Okay, guys?
Thank you
have a
very
good
much,
show,
Indy.
And happy birthday.
I'm gonna enjoy this show even more.
Yay, bye.
Thank you very much. Having said that, I'm super excited now that I feel a little bit old. Dina, take it away.
Well, that's a first, and it's really special, and I hope that everybody at home can just say cheers to Abram. And it's lovely to have life and to be with you this afternoon. But it's back to trig, and before the break, we were looking at how to find trig ratios using a calculator. We're now going to do the inverse. What happens when we would like to find the size of the angle? Let's have a look. Question 2 says to us, use a calculator to find angle theta. Okay, so before the break, we were working on an angle was given. All of a sudden, I do not know what the angle is. And we would like to determine what theta is if the ratio is given to you. So if we had to rewrite this, we would actually have that this is the same thing as a half. So if you can imagine what we're talking about, we would have a diagram with an angle theta, and where would the 1 be and where would the 2 be? The sine ratio tells us that it is always going to be the opposite over the hypotenuse. So we now have that this side here is the opposite, and this side here is the hypotenuse. Okay, it's O and theta, not the same thing. So we're really referring to that as one length or 1 unit, and the h as being 2 units. And what we're saying now is, please tell me what theta is. And that, mindset is what the power of trigonometry is I can give you 2 lengths of a triangle, and you can find, without measurement, you can find what the angle theta is. I can give you an opposite side and a hypotenuse, and you'll always be able to give us what that theta is. Isn't that powerful? You can be given the adjacent and the hypotenuse, and you'll be able to find theta. You can be given the opposite and the adjacent, and you'll be able to find theta. That is the power of trigonometry, to be able to find angles, which beforehand you've never been able to find except with the use of a protractor. The teacher said to you, please go and measure that angle. All of a sudden, I don't have to measure that. I can use a tool, a magnificent tool. These days you call them applications, an application called trigonometry, to be able to determine what the size of that angle is. So, how are we going to find that? Now, for that, we're going to go back to the calculator. We're going to look at some of these buttons. You will see that the button labeled sine, cos, and tan, those buttons will always find the ratios. That was what we were doing before the break. But the button that says sine to the minus 1, cos to the minus 1, and tan to the minus 1, it is not the reciprocal ratios. We can't make that mistake. This is the way that the calculator has been programmed, and you've got to understand how it's been programmed. Those buttons that are just underneath those functions will go and find that angle that you were looking for. Okay? And you must do this experiment at home. I want you to take a length of a unit on your opposite side, and I want you to take a length of 2 on your hypotenuse. And I want you to measure, once you've drawn that right angle triangle, I want you to measure with your protractor what that angle is. And you will see that it's going to become so close to the value that the calculator is going to give us now. So, when you're wanting to find the angle, you first have to press the button sine to the minus 1, which is not the reciprocal ratio, but it is the button, the function, the application that is going to go and get that angle for you. So we now have a half as our ratio, 0,5. And what is it going to give us? Would you like to guess, more or less, what that angle is? You'll eventually find that once you've worked with all the ratios of all the angles, that you'll get a sense of what the angle should be. But for now, as you're starting off with trigonometry, it's still a little bit new, so your prediction powers may not be that great, but they will become better with time. So sine of 30 equals, there we go, 30 degrees. So here we're now going to write theta is 30 degrees. Okay. Now we're going to do the same thing with cos. If cos is now the half, if our side is now cos of theta, and now we've got this as 1 unit, and this as 2. And by the way, if we do have this as a unit, let's just go back here. Let's put this as a 1, and this as a 2. What is the length of this side? What is the length of the adjacent side? Well, with Pythagoras, we know that that's going to be the square of 2 minus the square of 1, so this would actually be the square root of 3. Okay, but if we now have the adjacent side as 1, we now have the opposite side as the square root of 3. Okay, so they're in different positions. So theta cannot be the same as 30 degrees, because if it was 30 degrees, your adjacent would be root 3, and now your adjacent is 1. So it's very different. Okay, let's see what the calculator will give us. So to find the angle, remember it's the cos to the minus 1, and our ratio is 0.5. What does it give us? 60 degrees. Okay, so our angle is 60 degrees. So from your trig ratio to your angle, there's no calculation, because you go straight into your triangle, or you go straight into your calculator ratio, and you get the angle straight away from it. Okay, so if we now go further down, just so we can get this ratio, if we have sine theta equals 0.669, how do we find the angle? Find angle. How do we do that? Well, the calculator will find the angle by using the button sine to the minus 1. What you don't do is you don't put the sine to the minus 1. You go straight to your calculator, you find it, and you write it in here. Therefore, theta equals. Okay, now, when it was 0.5, we got 30 degrees. Now it's 0.6. Let's see what the calculator gives us. Calculator angle button of 0.669, the inverse. What is the angle? 41.98. Stick to your instruction with decimal places. I really find that with angles, 1 decimal place is sufficient, because your protractor doesn't have any more units than 1 decimal place. But you really do have to look at the instruction. If it says 2, you need 2 decimal places. So for us, for the time being, it's 41.9. Rounded off to 1 decimal place would be 42, and that's good enough for us as mathematicians. An angle of 42 degrees would be a good enough angle. Now, since we've been finding angles and sides, I want to link it to the trigonometry that we use when working with actual diagrams. So let's jump through to the slide that's got our triangle, and we're going to find sides and lengths, or lengths and angles. Okay, here's a nice example that will be able to do that for us. Triangle KLM has a length of side KL as 6.5. So here's KL's 6.5 centimeters. And we've got angle K as 34 degrees as given. And we need to find the length of LM. Okay, so that's the first length. Focal point, get your position with the angle. And where the angle is, this side that's unknown, what is its relationship to that angle? And the 6.5, what is its relationship to the right angle? Okay, very clear that this is the hypotenuse. And remember, the hypotenuse is the only one that does not change even when you change position of angle. It stays fixed. So that is the hypotenuse. This side, it's not difficult to see that this side is directly opposite the angle. So in other words, I want to find my opposite side, and I have got my hypotenuse. Remember the acronym we spoke about earlier? So, TOA. We have the hypotenuse. We have that one. We want to find the opposite. So can you see, because we have some information about the 2, we don't have anything about adjacent, we don't have anything about adjacent, so we've got too much missing information, we are going to use the sign. Okay, so LM, how are we going to do that? We don't have to write equals. We would start our calculation by saying that the sine of my given angle K would be my side that's opposite over my side that is the hypotenuse. And then we would substitute in the values. So we'd have sine of 34 degrees. Remember, a trig ratio cannot be written by itself. It needs an angle to accompany it. And the opposite side is LM. And the side that's the hypotenuse is our 6.5. And now we've set up a fractional ratio. We've got a fraction. We want to know what that numerator is, so we're now going to solve for that LM. We're dividing by 6, 5, so we're going to multiply by 6, 5 on either side. So it's 6, 5 times the sine of 34 degrees, which is equal to LM. And then we can use our friend, our little calculator, to say, okay, what is 6, 5? And we just punch it in that order, times our sine of 34 degrees equals. And it's telling us the length of that side will be 3,63. Now, in terms of lengths, if that was, I think it's in centimeters, 3,6 centimeters would make sense because I would get 36 millimeters. So one decimal place is good enough. 36 or 3,63, that's also okay, but 3 decimal places on centimeters would really not maybe make that much of a difference. So the context of the problem also guides you in terms of what decimal places are reasonable. So always have a look at that. If that was 3,6 kilometers, then 3,63475 maybe would make sense if I wanted to change it into centimeters, because I would need all those values for centimeter values. So it just depends what unit you're working in that you'd like to work with a specific kind of decimal place. But finally, if you are writing that exam and it's for assessment purposes, you will need to look at the instruction very carefully and adhere to that. Otherwise, you get penalized for not having used what the instruction suggested. Right, so that is 3,63, and we are here. So LM is 3,63 centimeters. Right, then MK. So if we go back to MK, we've got, let's work with green. There's MK. And as I've drawn it, can you see I'm drawing it next to 34 degrees? So it's the adjacent side to KM. And what happens when we are working with the hypotenuse and we want to find the adjacent side? Can you see I'm going to use the cos ratio for that? So we're going to do the same thing. Cos of the angle we're working with, which is angle K. Cos of angle K is equal to adjacent over hypotenuse. And that would be equal to, we have the angle, it was given to us as 34. The adjacent is what we're trying to find. Let's just go back, it's MK. So this, once you've written up your definition, then substitute in with the actual expressions for the sides. Your hypotenuse hasn't changed, it's still 6,5. And we now again have a calculation or an equation. So we can say 6,5 times cos 34 is equal to MK. Right, calculator is now going to help us. 6,5. Let's just go 6,5 times the cos of 34, and we get a value of 5,39. 5, so MK is 5,39 centimeters. Okay. Right, so that's a good example of how to find lengths of sides. Over to you, Abram.
Thank you very much, Dina. Having said that, it's time for me to go enjoy my cake. But mindsetters, be on the page. Let's chat and let's learn more. See you after the break. Welcome back, Mindsetters. And just know one thing, there's nothing that is difficult in mathematics. I'm hearing some comments of some Mindsetters on the page saying, we're still on holiday like Oscar. Come back, guys. It's time to work more and work smart. Chat with me over the page. We are on facebook.com/learn extra, or tweet me at learn extra. And also, you can download your notes for free on learnextra.co.za/live. But for now, more on Trig with dinner.
Thanks, Abraham, and once again, happy birthday. We really are having such a good time here. I'm hoping you're having a good time at home too, because I really, really love trigonometry, and I just think it's one of those very useful topics. People will often ask, what use is this mathematics to me? Well, trigonometry is one of those topics that's very useful for architects, designers, turners, fitters, boilermakers. They all use trigonometry in determining the various lengths of material shapes, etc., as well as the angles at which these materials are drawn at. So, very powerful tool that trigonometry is. And let's have a look at two problems where we could see trigonometry playing out in an active way. The first one says, a fireman's ladder is inclined at an angle of 58 degrees. The ladder is 10 meters long, measured from the top rung where the fireman is standing. How high is the fireman above the ground? Now, you might debate with me and you might say, well, how do you know that the angle is at 58 degrees? I think maybe we would rather know how high the man is above the ground, and we'd like to work out the angle at which the ladder is being placed. But nevertheless, let's work with the given information. And the best way to do any of these word problems is always try and draw a schematic view of what is actually happening. So let's draw a diagram and see what this thing really looks like. Okay, first of all, we see that the ladder is inclined at an angle of 58 degrees. So there is going to be a building, and there's going to be a ladder, and it is inclined to the horizontal at 58 degrees. Okay, so there's my ladder. In other words, my ladder is creating the hypotenuse. There's my hypotenuse. And if you think of this as the wall, and there's my window, let's say, and there's the ladder, then the fireman is standing somewhere over there, and he's going to climb the ladder to the top of the building. Okay, so every single bit of English can be put into this picture. The ladder is against the wall. We're hoping that somewhere along the line we know. Okay, from this picture, how high is the man above the ground? We are going to assume that we don't have the Leaning Tower of Pisa, but we've actually got a vertical building to the ground. So there's my ground. There's my building. And there's my ladder. Okay, so we've been able to draw a diagram of what is happening in reality, and now we're going to be able to translate even further and see, well, how does this relate into trigonometry? Well, the only thing we haven't used is we haven't used the 10-meter long ladder. So if the ladder is 10 meters long, we can make some interpretations here and say, well, the hypotenuse of my triangle is really 10 meters. And if you want to know how high is the fireman above the ground, then if he's going to climb the ladder to the top of the building, then he's going to be that high. And therefore, we would like to know how high the building is. Okay, so let's put that into a schematic view in mathematics. We would have the right-angled triangle. Without a right-angled triangle, I cannot operate on any trigonometry. We've got a ladder that's inclined at 58 degrees. We've got the ladder that's 10 meters, and we want to find out what this value here is. So we've got this as x. Okay, so how does my problem now translate into mathematics? Is that the value that I want is actually the side that's opposite. Remember, the 10 is opposite the right angle, so it's fixed. It is the hypotenuse. It can't change. And we would like to find the side that is opposite the angle. So from our acronym that we had earlier, so Katoa, let's place what we know on that acronym. We know the hypotenuse. We want to find out what the opposite is. So 2 pieces of information we have, I'm going to therefore use my sine ratio. So I've got the sine of my angle 58 is equal to my opposite, which is what I don't know, over my hypotenuse, which is 10. So my unknown height of my building is simply 10 times sine 58. And our friend, the calculator, will help us out, because 10 times sine 58 is 8,48. So the fireman is 8,48 meters above the ground. Okay, so a very, very powerful way of finding lengths is to be able to draw a diagram and then interpret it in terms of the trig. But remember to look for that right angle. Otherwise, the trig is useless at this stage. Next year, when we're in grade 11, we'll look at what happens when triangles are not right-angled and how will trig help us then. But you've got to wait till next year. Right, there's 2 more concepts that we need to look at, and that is angles of elevation and angles of depression. And elevation is really what it's saying. It's something that's been elevated and how it's measured. And depression is a little bit different. The word depression in today's society has got quite a disease sort of mentality to it. But in mathematics, it's not that at all. Depression is just when you're measuring something and you're going below something else. So how depressed this thing is. It's got nothing to do with the psychology. All right, so angle of elevation is an angle starting from the baseline and moving in an upward direction. So you would have a horizontal, and when you are looking up at something, you would talk about an angle of elevation. Whereas the reverse, or the inverse of that, would be if you are watching, you are stationed in a place, and you are watching something below you. So if I was looking at the ground, for example, I'm looking at an ant that's walking on the ground, then I would measure my angle from a horizontal all the way to my line of sight. So this would be my line of sight, and the angle that's measured would be from the horizontal. Okay? And that is what we call an angle of depression. Okay, so let's see how this works out in a problem. The angle of depression of a boat. So when I talk about an angle of depression of a boat, it means that there is a line of sight to the boat that is going from a horizontal down. From the top, and you'll see, actually are told that you're looking from the top of a cliff that is 65 degrees. The boat is 80 meters from the foot of the cliff. This needed just a little bit more information of a vertical cliff. Otherwise, this cliff could be at an angle that's not at right angles, and therefore we would have a problem. We wouldn't be able to answer this question. Okay, so what's happening is you're on the top of a cliff, and you can see a boat out at sea. Okay. The angle of depression is measured from the horizontal. So I'm going to draw my horizontal, and I'm going to measure that angle of depression. And it is 65 degrees. And then I see a boat out at sea. Okay, there's its sail. Okay. And this boat is a certain distance from the vertical cliff. Okay. What is the angle of elevation of the top of the cliff? The angle of elevation, if the person is standing at the boat and looking up at this person, will be exactly the same. So this angle will be 65 degrees. Okay? And calculate the height of the cliff. Well, how high is the cliff? And we know that the boat is 80 meters from the foot of the cliff. Sorry, they did tell you that. It's 80 meters. So how high is this cliff? We would like to know what is the opposite if we have the adjacent. So we would take tan of 65, because it's my opposite that I don't know, over my adjacent, which is 80. And our friend, the calculator, will be able to tell us what that is. So it is 80 times the tan of 65, and we get that the height of the cliff is 171.56. So the height of the cliff is 171.56 meters. Right, over to you, Abram.
Right, thank you very much. Having said that, it is time that we move on and tell you what's coming up next. It is another great show for grade 11, still on mathematics. We'll be doing functions, and we'll be having a draw to you, Mindsetters, for a lovely competition that we've been having, giving away certain books. But having said that, thank you very much, Dina. We'll see you, Mindsetters, right after this. Goodbye.